Now let's learn chemical properties of metals and nonmetals. Chemical properties of metals and nonmetals. Let's see the first chemical properties. The first property is about valence electron. In the case of metals, the valence electron will be either 1 or 2 or 3. In the case of metal, the valence electron will be either 1 or 2 or 3. You know about valence electron, right? Yes, the electron present in the outermost shell is known as valence electron. They have given the example of sodium. Atomic number is 11. What is the electronic configuration, children? 2, 8, 1. How many electrons are present in the valence shell? 1 electron. Let's see another example, children. Here in the case of magnesium. What is the atomic number? 12. Right? Yes. What is the electronic configuration? 2, 8, 2. How many electrons are present in the valence shell? 2 electrons. Okay. Next is aluminium. In the case of aluminium, the atomic number is 13. So the electronic configuration is 2, 8, 3. How many electrons are present in the valence shell? 3 electrons. Got it? Yes. That is for metals. How many electrons are present in the valence shell, children? 1 or 2 or 3. Let's see in the case of non-metals. For non-metals, the valence electrons will be either 5 or 6 or 7. For non-metals, the valence electrons will be either 5 or 6 or 7. First, in the case of phosphorus, children, atomic number is 15. Got it? Yes. What's the electronic configuration? 2, 8, 5. Okay. How many electrons are present in the valence shell? 5 electrons. And in the case of sulfur also, atomic number is 16 and valence and electronic configuration is 2, 8 and 6. How many electrons are present in the valence shell? 6 electrons. Okay. In the case of chlorine, the atomic configuration is 2, 8, 7. 7 electrons are present in the valence shell. In the case of nonmetals, the valence electrons will be either 5 or 6 or 7. Nonmetals, generally it consists of 5 or 6 or 7 valence electrons. In the case of metals, generally it consists of 1 or 2 or 3 valence electrons. Got it? The second property is metals are electron donors. Okay, metals are electron donors. See the example, children. In the case of sodium, what is the electronic configuration? 2, 8, 1. Right? Yes. Whether it will lose that electron, that 1 electron, or it will accept 1 electron, children? It will lose that electron, right? Yes, to attaining octet configuration, it will lose that 1 electron. Okay? So, metals are electron donors. Whereas in the case of non-metals are electron acceptors. Okay? Non-metals are electron acceptors. In the case of chlorine, what is the electronic configuration? 2, 8, 7. 7 electrons are present in the outermost shell. What it will do, children? Whether it lose 7 electrons or it will accept 1 electron? It will accept 1 electron, right? Yes. So, we can say that non-metals are electron acceptors. Okay, metals are electron donors and non-metals are electron acceptors. Second one is clear, children? Yes. Metals are electron donor and non-metals are electron acceptor. And the next property is metals are electropositive in nature. Metals are electropositive in nature. I told you metals will donate electrons, right? Yes, it will donate electrons to form positive ions. So we can say that metals are electropositive in nature. Can you see the example, children? In the case of sodium, 281 is the electronic configuration. It will lose the outermost electron to form Na plus ion. Okay, Na plus ion. Positive ions are called cations. Okay, that is metals are electropositive in nature. Non-metals are electronegative in nature, children. Okay, in the case of chlorine 287, I told that non-metals are electron acceptors, right? Yes. In the case of chlorine, one more electron is needed to attain octet. It will accept one more electron to form negative charged ion. That is chloride ion is formed. Okay, Cl minus ion is formed. What is called a negative charged ion? Negative charged ion is called as anions. Okay, in the case of non-metals, they are electronegative in nature. In the case of metals, they are electropositive in nature. Then we have our last point, metal oxides are basic in nature. Okay, metal oxides are basic in nature. You can see Na2O, sodium oxide, and K2O, potassium oxide, calcium oxide, and magnesium oxide. All are basic in nature. Metal oxides are basic in nature, whereas non-metallic oxides are acidic in nature. Okay, example, in the case of carbon dioxide, CO2, SO2 and NO2. Okay, how will you know that? Okay, it's simple, children. When CO2, when you add water in CO2, what will be formed? Comes carbonic acid. Okay, carbonic acid you add in soft drinks. When that is non-metallic oxide are acidic in nature. So too, when you add in water, then what will form? Sulfuric acid, NO2. Similarly, in the case of NO2, when you add water, then what will form? Nitric acid. Okay, that is non-metallic oxides are acidic in nature. You prove metallic oxides are basic in nature. In the case of sodium oxide, when we add water, what will be formed? Sodium hydroxide, right? Yes, sodium hydroxide is basic in nature. Okay, that is metallic oxides are basic in nature and non-metallic oxides are acidic in nature.